there's that. Block that for just a moment. Good morning, Z. Welcome. Welcome to our class today. Happy Friday Eve. I'll say that again when everyone gets in here. 2021, 06, 17, and this will start us out today. Objects. Okay. And then I'm going to pull open this, which I should have saved yesterday. No. All right, let me kind of clean up this stuff. Good morning to you. Welcome, welcome. Welcome to the party today. That's fine. Let me just pull this over here. Let's see how many people we got. Roughly. We got about 6 people, so I'm sure about 6 to 10 more people will trickle in here slowly. It is 11:20 though, so we're going to get started. The first thing I'm going to do is just check my microphone. That looks good. And why are you doing this to me? That's not cool. That is not cool. All right. All right. So before we start talking about the code, I need to make some announcements, as I kind of always do. My first and favorite announcement I'd like to make is Happy Friday Eve. It is Thursday today, so we are working on those pointers still. Tomorrow, whatever we don't finish today, we're going to talk about tomorrow, and then I'm going to kind of do my best to do a review. So that means today I will be uploading a review sheet. It's going to have a bunch of questions based off of these things we've talked about: classes, inheritance, and pointers, dynamic memory. And like a practice coding question. And tomorrow we're going to go over all of that. We're going to do our best to go over all of it. Z asked how many questions will be on the test. Anywhere between, let's say, 24 to 30 questions or so. The questions are all over the place. So some of them are multiple choice. A lot of them are multiple choice. Okay, let me rephrase that. 96% of the questions are multiple choice short answers and short coding. So if you know what you're talking about, I guarantee you can answer those questions in under 2 minutes. The last question is a big coding question. You have to write a whole program, and so likely that's going to take some time. So maybe, it's different for everybody. Now, the whole program is not going to be like the assignments, okay? It's going to be something simple. I'm not going to ask you to calculate the average distance between cards in a deck, but I am going to make you write a program that uses these things, classes, inheritance, and pointers, something like that. So, probably roughly, an hour or so for all of the smaller questions and 30 minutes for that big programming question, something like that. You can see the point values of all the questions. So if you're having trouble with one and you look at it and it's a measly 2 points, you can say, I'll come back to it later. And you go focus on the ones that have higher point values. So as I said, tomorrow, if we don't finish up all of our pointer stuff today, we'll kind of finish it up first thing in the morning tomorrow. And then I'm going to be going over a review sheet. I'm going to be answering those questions one by one. Before tomorrow night, the answers for all of the review questions will be uploaded. So you have 2 days this weekend to study that stuff. Maybe even print it out if you want to. But keep in mind the test. Here's how my review sheets work. I ask you general questions that kind of, if you can answer them, then you have a general understanding of what that subject is. So a lot of, instructors, and I've taken, geology before and stuff, they like to, they put questions on the review sheet that are exactly the same questions that are on the test. I may have one or two of those, but it's not going to be the case for most of them. You're still going to have to think. You're going to have to think about that stuff. So, so all I'm saying is I think you definitely should, print out that stuff, but it won't be a walk in the park. You're not just going to be kind of copying from your notes to the WebEx, to the Web Campus test. You're definitely going to have to use your brain on some of it. And that's partially because, we are virtual. If this was in person and I could proctor it, it would be different, but it's virtual learning, so we're kind of mixing it up a little bit. But don't worry, you'll be fine, I promise. For those of you who are participating and look at that review sheet, I assure you, you'll do fine. So now that we've talked about that, I'm going to kind of go over quickly the stuff that we talked about yesterday. And then we're going to move on to our stuff. So I'm going to get rid of that. I already kind of talked about this stuff yesterday, or 2 days ago. But some of the new things we talked about was maybe the size of, which tells us the size in bytes of some variable. And we also talked about the brackets, right? Brackets we've been using since CS 135. And what are they? It's a dereference operator. It's a dereference operator. And all it does is it adds a certain number of bytes to the address, and then it dereferences it. So as you can see here in this example that we talk about, x indexed at 3 is the exact same as x plus 3 times 4, right? What is the size of an int? It's 4 bytes, so it's 3 times 4 bytes, which is 12. So it's the address plus 12 bytes dereferenced. So they're exactly the same thing. We talked a little bit about addresses being hexadecimal. This stuff was from the previous day. And then we introduced pointers, right? Pointers are variables that hold addresses. And remember that pointers have their own type. And that tells us, how far should I dereference on this address? If it's a double, I'm going to dereference 8 bytes. If it's an int, I'm only going to dereference 4 bytes. If it's a character, I'm only going to dereference 1 byte. So that's why pointers have types. That's the syntax, right? We're going to be using more pointers today. So if you still are confused on that, don't worry, you'll see it. And recall that with pointer arithmetic, you can add and subtract, but nothing else. Nothing else. Do not try to multiply or divide an address. Here's the formula, right? That's a good kind of test question. Here's the formula. When you add something to an address, what does it look like? Well, it's address plus whatever x is, which is an integer, times the size of the type of the variable. In this case, it's an int. I guess this should be type of type. This is why we go back through these things. It's the type of the address, right? It's this one. It's the type, whatever this address is. If it's an address for an int, this is the int. This is an address for a double. This is a double. So something very important you should consider is as long as a pointer contains an address, that means we can store values there. And we can, in the order to do that, we're going to dereference the pointer on the left-hand side to do that, right? What am I doing? So, recall, if I have a pointer, this is all review, and I have an address. In this case, I'm going to use this x for the address. As long as I have an address inside of that pointer, I can dereference that pointer on the left-hand side of the assignment expression and assign some value into it. So that's what I'm talking about there. I'm allowed to do that. And so what do we do here? This kind of, goes to the location and opens the box, and then we can put something inside of it. So I talk about that there. Now recall null and null pointer, right? It's equivalent to 0 or empty. And whenever you have a segfault in your program, it's likely because you dereferenced a null pointer. Oftentimes this happens when you go out of bounds on arrays. So if your program is ever segfaulting, the first thing you should look for is, do I have any pointers that contain null? And am I dereferencing them? And number two is, am I going out of bounds on any arrays? I better check my for loops, stuff like that. And now I have to wonder why I put this here. What if I would like some memory during runtime? Right. So that's where we talk about that, right? What if I do want some memory during runtime? How do I do that? Well, I'm going to call new. I'm going to call maybe new type here. So we'll review that. And then we also got to talk about our dangerous pointer things. So once again, I asked this question, what if I want memory during runtime? Why do we do this? Well, as answered yesterday at the end of class, what if we don't know the size of our CSV file? What if we don't know the size of the data we're working with? Well, if that's the case, we cannot tell the compiler beforehand how much memory we'll need. So this is why we need to request memory during runtime. And that's why vectors have been so handy for us, because whenever we declare a vector, we can continuously add stuff to it. And you want to know how that vector works? Well, that vector is calling, or it's requesting memory from the operating system. So what are the functions that we use? Well, we use new, right? So if I actually wanted to assign a new address to this pointer, I can say iPointer is equal to new int. Now, why do I say new int? Well, that is because it's an integer pointer. If this happened to be a double, I would say, please give me a double. Now, why do we do that? Well, the reason we do that is because I need to notify the operating system how much memory is required, right? So not only do I need the starting address, but I also need to reserve that many bytes of memory. I need to reserve that many bytes of memory. So we talked about that. I have so many notes open right now. Let's think about, I think that's where we are. What about this one? Or close this one. Recall you must use a pointer to store this address. And here you have some examples of that. Now delete, for every new, you must have a delete. Okay, let me put that here. For every new, you must have a delete. Otherwise, you're going to have a memory leak. Okay, so for every new, you must have a delete. And deletes probably happen at the end of the program most times. Today we'll learn some examples where they're not at the end of the program. But this returns the address to free memory. This notifies the operating system that the program is no longer using this address and says you can have it back. So in the case of this, when I've done whatever I want with my pointer, I say, hey, iPointer, is equal to 3.14, and then I do some math. And then down here, before I return, I need to say, hey, delete this address. Say, here you go, operating system, you can have this back. I'm no longer using it. If you forget this, the program will exit, and the operating system still thinks that this program is using this address. And in a way, that address is lost. It's gone for the time being. So always remember this. All right, let's see where we're at. Now we briefly introduced how arrays work. Now they work the exact same way as this does and this does, but instead of just requesting a single one, we're going to request multiple, right? So I can say, please give me an array of 4 doubles. And if I say that, then I'm going to want to delete it with the brackets, which indicates that this was an array and not just a single double. So they work the same way. We're going to be working with this kind of in depth today. And then the kind of last thing we were working on was the dangerous things with pointers. Now a dangling pointer happens when you delete the address, but you don't overwrite it, right? So notice here, I've deleted the address, but down here, I could still say something like pointer 4 is, maybe not 4, but maybe 2 is equal to 7.0. I've returned this address to the operating system, but I still have it stored in here. I still have it stored in here. And so I can still access it. And so chances are, if I do this, I am accessing memory that I'm not allowed to access. This memory could belong to another program like your Minecraft server, and you could just overwrite your health bar or something. You never know. Okay, so this is called a dangling pointer. To fix dangling pointers, you always need to do this, in which you may want to package these things always. Kind of do both. Do both. Always do both. Just say, hey, delete it, and then overwrite it. Make sure that we lose that address. I don't want it anymore. I know it's not mine. Now, memory leaks are as what I talked about before, which is an address that's not returned to the OS. There's 2 ways these happen. One is you overwrite the address before calling delete. So what does that look like? I say something like iPointer is equal to new double. At this point, I've created a memory leak. And the reason for that is there's an address in here that it's an old address, right? And so this old address I was using, and then I overwrote this. I overwrote it, and now I'm going to say, where's my old address? I can't reach it. So before I do this, I need to make sure that I call delete to prevent the memory leak. Now, another way that happens is, let's see, and I did this wrong. Make sure you call delete here. And lastly, another way a memory leak is caused is I do not delete it before the program returns. So I request memory, and then nowhere in here do I delete it, and then I return from the program, Memory was never returned to the operating system. Therefore, we have a memory leak. And lastly, we're talking about aliases. Now, I already mentioned this before, but this is when two variables, two pointers, I guess, contain the same address. Why is this dangerous? Well, if you change one variable, you change the other. I showed you an example of that yesterday. Now, there's really no good reason to have an alias. There really is no good reason. If you're going to change one variable, you're going to change the other one, so you might as well just have one of them. Okay? So that's our brief review. That's our brief review for today. Now we're going to get started on the new stuff. Is there anything that you guys would like me to revisit that I kind of quickly went over? I don't mind. Just let me know. But now we're going to kind of introduce, there's a few things we'll talk about today. One of them is we're going to work with these arrays, okay? We're going to work with these arrays so you can get a better understanding of that. We're also going to work with, actually we're going to work with all of these operators today. We're also going to introduce the idea of a class. We're going to introduce the idea of using pointers with classes. And we're going to talk about this idea of a deep copy and a shallow copy. And then if I get to it, we're also going to talk about using Valgrind. Valgrind will be kind of my last thing that I'll get to, if anything. Yeah, so that's pretty good. So once again, just let me know, and we'll get started here. Hello. All right, so today we're going to start with a class, okay? And so we're going to kind of introduce just a quick little example of something. And that is, if you remember yesterday when I was talking about null, I was kind of giving you the example of from assignment 1 when we're putting -1 values inside of integers. And how I would prefer not to do that because -1 is already a valid integer. And how do you know that it's not a valid value, you know? And so the class we're going to develop today is just called container. We'll call it maybe an int container. And this container will just hold an int, okay? It'll basically be just an int variable, all right? So nothing super fun, you know. We're not going to be solving a Rubik's Cube in C++ today. We time out. Should we all hit refresh? My connection is good on my side. Yeah, I'm seeing, should be good. All right. Thank you. Thank you for letting me know. So today we're going to use a container. The idea of a container, it'll be for ints. It can be empty. Because it can be empty, we're going to use a pointer. We're going to do pointer stuff. And this will really help us talk about a bunch of stuff today. So let's just get started with that, and we'll kind of code and do notes at the same time. So I'm going to call it an int container. All right, and this is our class. Now there's only one private variable that I'm going to use in this class, and then a bunch of publics. The private variable I'm going to consider for a container is going to be the actual pointer. It's going to be the, I'll call it an I pointer. All right, and this will hold the int. Or it's empty. All right, so that's what this variable is going to do for us. Either we have an integer or it's empty. And now we're going to do a whole bunch of stuff for this class. A whole bunch of stuff. So we'll start first with the default constructor. Does anyone have any guesses, based off the notes we talked about? In the default constructor, how is that called? Well, we'll say something like int container, my container, something like that. The default constructor is called here, right? What do you think we should initialize our iPointer to be in the default constructor? So I have an int container here. This is our default. And today I'm going to define everything outside of the class, if you don't mind. I think we could all use an example of that some more. These are going to be our class definitions down here. This is not SQL. And then this will be main. All right. Yeah. Well, a lot of you said null. Very good. Yes, that should be null, right? So we're going to initialize this to be null because I want it to be empty. You can use null or null pointer, either one. C++ is ambiguous sometimes. Ambiguous means you have multiple things that mean the same thing. Now, specifically because this is called a pointer, I'm going to use null pointer, okay? I'm just going to use null pointer. All right, so that initializes it. Done. We're done with that. iPointer is null pointer. Now, for those of you who are still, a little bit confused on this stuff, I just want to show you that if you didn't do this, this pretty much does the same thing. All right, I don't know who that is, but don't say that. I hope that wasn't a. I hope that wasn't an actual student, and if it was, then they're going to be sad that they said that. Yeah, I think that's definitely a troll. Once again, this is on Twitch, so I'm sorry if any a random person comes in here and says something offensive. It does not, reflect what I want for this class, okay? So I will always ban those people, and I'm sorry if we ever see something that we shouldn't see. For the most part, I've never had any of that. Usually I just get the people who say, get free followers or something. And of course, if you do have a problem with that, you're always welcome to contact me, and we can work out an alternative if we have to. But I think we're all we can be thick-skinned here, right? All right, so that's our default constructor. Now let's do the parameter constructor. It's going to take an int, and we'll just call this the param, right? So let's come down here, do that same thing. This is going to take an int x, something like that. And we could do an inline initialization if we wanted to, but let's just start with something. So what's the first thing I should do if I want to store this x into the pointer? What's the first thing I should do? Where's mine? I for what? All right, so that's good. But what's going to happen, little attacker, if we do that? Probably a seg fault because we're dereferencing something. So does this pointer contain an address yet? Is the question I'm asking. So you want it to be equal to this address. So I'm okay. Well, that might work. Okay, but guess what this is? This is a pass. This is a pass by value. All right, so this is a copy of X. So when this constructor is done, this actually gets deallocated, and then we're going to be looking at memory that we don't have access to. So this is correct. This is correct, but we have to do something before it. What is that thing we have to do? Let's look at our notes. What's that thing we have to do? It's that. Yeah, yes. We have to do that. So we have to say, all right. So what does this do? Give me an address. And then put the value inside. Yes, we have to give it an address. We have to give it an address first. So it's very important. Now, here comes the destructor. Here's the beauty of the destructor. Cherry asks, isn't star I pointer contain an address? At this point, we don't know. So at this point, I pointer is probably initialized to some garbage value. And so if there's a garbage value in there, we'll try to dereference it and store X inside of it, which may give us a seg fault. So once we allocate this, that means this here returns a new address and it puts it inside of it. And then once we have that address, we can put X inside of it. So hopefully that makes sense. So we're probably going to need a destructor. And the best part about this destructor is that we can deallocate that address when this object goes out of scope. So notice down here in main, if we declare this, this container is going to go out of scope down here, right? And it would be really annoying if we had to type this every time. Now, of course, this wouldn't work because iPointer is private. But if we had to always watch, for this, it would be very annoying and people would forget it all the time. So the reason we have destructors is so that we can deallocate that pointer automatically. So let's do that. By just calling delete on iPointer. Now, there's a small problem here. So let me go to my notes and just put it there. You cannot call delete on a null pointer. So if I call delete on this iPointer and it's equal to null pointer, our program will it'll die. It'll say something like double free. It's not going to work. So the first thing that we should actually always check for is if iPointer does not equal null pointer, then let's go ahead and delete it. Does this make sense? iPointer not null, delete it. Thank you. All right, so this already prevents memory leaks. So in here, whenever we declare a container, let's say we give it a value. We say, I want my container to contain 5. This calls the parameter constructor. So it goes to it, and it allocates, it requests memory from the operating system, and it puts that value inside of that address. And then, whenever this goes out of scope, right, somewhere down here, the destructor will be called, and it will automatically return that address to the operating system. I had a little bit of a stream hiccup there, so please notify me. I didn't say anything new, I promise. Cherry asks, is this something we frequently do when defining the destructor? And I would say yes. Write that down if you want. Destructors pretty much are for this. Destructors are pretty much completely for this purpose. Thanks for notifying me. So that's really something important to consider, is that, you know, if we have a static variable that keeps track of, say, you know, how many players are in the game, the destructor could be used for that, absolutely. But also, this is the main reason, to deallocate memory that we've allocated. So that's a very good observation. So that's pretty much kind of where we're going here. Now I'm going to introduce something to you guys, and we're going to first talk about shallow copies and deep copies. Have any of you ever heard this term before? I wonder if it would be mentioned in pass by reference or pass by value kind of ideas. No? Okay. So a shallow copy is an alias, kind of by definition. Meaning that you only copy the address. So let's do a paint. Let's do a paint. Now that I'm starting to do more kind of whiteboards here. I think someone told me last semester that they prefer the inverted colors. What does this do? All right, yeah, I definitely want to see this. All right, so let's pretend we have an int value. All right, so I'm gonna have two int pointers. So let's make that. Guess I have to make it visible. So we're going to have two pointers, int pointer 1 and int pointer 2. Now, let's say we say this. Int pointer 1 is equal to new int. And then below that we say, we dereference it, and we say pointer 1 has this value 5. So when we call new, this pointer is going to get a spot in memory. Here it is. And inside here, so in here we're going to have a 5. And this is probably going to have some hex value, 0x02. Yeah, I think we're having all sorts of problems today. The world is saying, Mr. Petrowski, today you cannot have a good streaming day. It's going to say, you know what? We're going to have connection problems. We're going to send these annoying people to your stream. Your computer's going to freeze during class. I guess I just can't have a nice day today. So tell me if I need to go back, but I don't think you missed very much. So what do? We declared a pointer, we allocated an address to it, and we assigned 5. So here is pointer 1. And so in a way, this pointer, let me draw a little arrow. Yeah, there we go. Is pointing here. Okay? Oh, cool. So this pointer is pointing here, and this is where it. That's its address. So now we type this code. Somewhere in here we say pointer 2 equals pointer 1. So now what happens? Well, they are now pointing at the same address. And so whenever we change pointer 1, we're going to change pointer 2. Whenever we change pointer 2, we're going to change pointer 1. This is what's called a shallow copy. Yes. Shallow copy is an alias. So what we call a shallow copy. So, how do we make a deep copy? Does anyone have any ideas? I'm going to save this picture here so I can put it on Web Campus. I'm going to keep a few things. Yeah, I am going to keep a few things. Let me just kind of get rid of stuff. Say goodbye to this thing. Say goodbye to this thing. Say goodbye to this thing. All right. Yeah, so Cherry says you make a new address first, right? So step 1 always for a deep copy is to make a brand new address. Or to request one, rather. So in order to do that, we're going to say pointer 2 is equal to new int. And then what's the next thing we do? Can anyone tell me? Not a trick question. What's the next thing we do? I'm going to wait for a guess on this one, because understanding how pointers work are very important for safe programming. All right, so we have set pointer 2 equal to pointer 1. And I'd say, no, that's the shallow copy. But Cherry got it right, right? You dereference it first. So maybe that's what you guys meant. So I don't blame you, but we have to dereference it. Here's the most important thing to understand. You see this? This must exist. All right, you must have these stars here. If you do not have the stars, shallow copy. If you do not have the dereferencing operator, shallow copies. And shallow copies in general are bad. I would say 99.9% of time shallow copies are bad. So, always dereference them first. Is there any confusion about what I'm doing here and why this is different than a shallow copy? Let me even let me just show it to you. I don't know why this Microsoft program Photos takes years to open, but they should really work on it. So notice here, that line of code that you guys said, right, pointer 2 equals pointer 1, That's where the shallow copy happens all the time. That is where the shallow copy happens, right here. So you have to put the stars here, and before you put the stars, you need to allocate. You need to allocate. You got to do that first. So this makes a deep copy. So you know what that means? When we come over here and we say, hey, let's kind of copy this, it'll be here. But guess what? This is probably going to be something else. This might be 0x04. Okay, do you understand? And so what is this point at? Well, if we grab our curvy little thing, whoop, it's pointing here, right? There we go. So that is a deep copy, meaning that pointer 1 and pointer 2 have their own addresses, but they contain the same value, right? So that's a deep copy. And so usually whenever we do stuff, we're always going to want to deep copy. And so now we're going to kind of put this in our notes a little bit, and then I'm going to talk about something when we do deep copies and shallow copies with classes, why it's important. So this is a deep copy. All right, a deep copy is you only copy the address. So an example of that, as I already showed you, but just so we have it in our notes, we're going to say, int pointer 1, which is equal to a new int. And then you have int pointer 2, which is equal to pointer 1. In that case, you do the shallow copy. In the deep copy, you're going to say int pointer 1 is equal to a new int. Int pointer 2 is also equal to a new int. And then we're going to dereference pointer 1 and set our pointer 2 and set it equal to the dereferenced version of pointer 1. All right, so that's a deep copy. And so given that, we're going to talk about something now called the rule of 3. When should we consider the rule of 3? This is when we have a class that contains a pointer. All right, so this part's very important. So please listen and do your best to ask any questions about this so you understand what's happening here. So we have to consider the rule of 3 always when we have a class that contains a pointer. In this case, we have a class and it contains a pointer. So we have to consider the rule of 3. Now I'm going to add a little comment here for this. This is the rule of 3. And there's two things that we need to talk about first. So every class always has these things. The compiler will assign them. It always has a default constructor. It actually has 4 things. It always has a default constructor. Maybe not always. I'll take that part out. It always has a destructor. It always has a copy constructor. And it always has an assignment operator overload. Now this is scary, meaning we haven't learned it yet. So we have not learned yet. So this part will not be on the test. All right, so learning how to do this, well, I'll kind of just wave my magic coding hands today. But every class always has these things, all right? Every single time. A copy constructor is a parameter constructor. You can have multiple parameter constructors. Hulu asks, that's the equals, right? And that is correct. So I'll give you the example of these. So this is why the compiler needs these things. So if you have an int x and you have an int y, you can say x is equal to y. What does this call? This is the assignment operator. All right? That's the assignment operator. Now, there's also something else you can do. You can say int maybe w and int z, and you can initialize z to be equal to w, or something that looks more like this. Now this is confusing because assignment operator maybe? Question mark? Well, no. The reason that the assignment operator is not used here is because z is a brand new variable, and the compiler knows that you're trying to initialize it with this w value. So whenever you do this, it's the exact same thing as this. Please tell me if this is confusing and you need me to explain this better. The compiler knows that you're trying to initialize this z value with w. So it's essentially calling the copy constructor here. Even though the assignment operator is being used, the copy constructor is here. And then last thing I want to mention is that the destructor is always called when something goes out of scope. All right? All right, and so that's why every class always has these three things, even if you do not define them. All right, let's put that in our notes. Even if you do not include them. All right, so you always need to consider this. The moment that you put a class in here, the compiler will say, hey, you're going to get a destructor, a copy constructor, and an assignment operator overload. Ali wants me to talk about the copy constructor, and yes, so I'll do that. So here, I'm creating a brand new object, right? I mean, I'm just using ints for an example, but the first thing you need to know is that I'm creating a brand new object. Notice here, I'm doing the same thing here. I'm creating a brand new object. And then I'm trying to initialize that value with another object of the same type. So notice that int z is an int, and w is also an int. So they are objects of the same type. And I'm telling the program that I want this object to contain the same value that this object contains. And so since I'm declaring a brand new object, a constructor will be called. What constructor is going to be called? Well, since I'm providing a parameter, the type of this parameter is int. So up here, you're going to see something like this. It's going to take a const int container copy. This is a copy. This is what the copy constructor looks like. So notice that this is a constructor that's taking a copy. It's taking an object of the same type. And so because there's an object here of the same type, that is the constructor that's called. And so these are the same thing. I know it's confusing because of this equal sign, so maybe we'll just leave it out for now. But all I'm saying is the compiler knows that this is the copy constructor because you are making a brand new object. So did I hopefully clear that up a little bit? The reason that the copy constructor is not called here is because these objects are already alive. X and Y at this point are already alive, and they contain some value. So this is why the assignment operator is called here. Here, we're making something brand new, and that's why we call it a copy constructor. So Ali, let me know if I need to clear something up. And then last thing, avert your eyes, or don't. If you think you can fit it in your brain now, then please do. I'm going to do the operator overload now. Okay, we're going to talk about this very soon. Yes, you are welcome. We're going to talk about the operator overload very soon. Let me show you when we're going to talk about it, so you can look forward to it. As I said, it's fun stuff, as always. The operator overload is coming up next week on Thursday, all right? So next week, we'll talk about what I'm about to do, but I need to introduce it now because of the rule of 3. Coding is never perfect, and I can never do things in a streamlined fashion. But avert your eyes if you don't think you can fit it. And maybe I'll make these vertical so we can see it. So our destructor here. This is our copy constructor here. And then this is our operator. This is our assignment operator overload. So notice, I'll just kind of point it out. I'm not going to really answer questions about it, just as long as you know kind of how it works. This is essentially a function, okay? This is essentially a function. And so let's pretend I have this int container here. And I'm going to change their names because I want them to be small. So this is going to be IC1, and this is going to be IC2. Now at some point, I'm going to say IC1 is equal to IC2. Now this is the exact same thing as saying IC1 dot call this operator and provide IC2 as a parameter. All right, so just pretend for now that this is a function, okay? Just pretend for now that this is a function with this wacky name. All right, this is a wacky name called the operator equals, all right? And they are the same. Should make sense though. This says please set IC1 equal to IC2. Maybe I'll make them backwards, something like that. All right. So guess what? If you let the compiler do this by itself, let's see. If you let the compiler automatically generate these 3 things, it will make shallow copies. So let's make an example of that. So let's do this copy constructor here, okay? All right, so this is the copy constructor. Maybe my face is in the way a little bit, so we'll bring it down. So, what would the shallow copy look like here? I'm going to ask you guys to take a guess at this one, just, you know, for a little bit of class participation. What would the shallow copy look like here? And maybe I can just bring this up in front of your face to give you a little bit of a hint. I think that will look okay. And I'll give you a few moments here. Recall that these int containers, the pointer is here. It's called iPointer. So if this is called iPointer, what does the shallow copy look like here? I'm going to say no to that one. Yeah, so I'll call you 420. We're all adults here, right? So 420 says I pointer equals I pointer 2. That's the closest one. So please tell me if this is confusing. I'm going to say that I pointer. Now, which I pointer are we talking about? We're talking about the I pointer of this object. Do you recall me mentioning that before? I'm talking about the this one. Right? So if I call the copy constructor here, this is param now. If I call it here, this object will be IC2, and then the copy parameter is IC1. So basically, the shallow copy looks like this. Does it make sense? Why are you... Yeah. Does that make sense that this is the shallow copy? This says take my object here and assign this address into it. This is what the compiler will do. Synchro asks why copy.iPointer. So pretend we're looking at this line of code here. So I'm declaring a brand new int container IC2, and I'm initializing it to another parameter. I'm initializing it to be equal to this int container IC1. So essentially I'm saying I want this int to be equal to 5. So this calls the copy constructor. And so when we call the copy constructor, we're going to go into here. Here's the copy constructor. And so what is IC1? It is this object. All right, so iPointer, we're talking about IC2. We're talking about its iPointer. So we're looking at IC2 from this perspective. Now, what is this? This is the copy. This is the parameter, right? This is a parameter, just like a function. So what did we pass in? We passed in IC1. So copy dot iPointer is IC1's pointer. Does that clear it up? In the sense, we'll say assign the pointer inside of IC2 to be equal to the pointer inside of IC1. Yes. Yeah, exactly. That's exactly what's happening. It's copying the first int container's pointer. Well, it's copying this int container's pointer into this one. The compiler generates this one automatically, and it makes a shallow copy. And so pretend this. Let me show you. If true, so Cherry asks, is that why we use the assignment operator overload to avoid that? That's exactly right. So I'll just kind of briefly mention this. For the rest of your life, copy constructors and assignment operators are almost the exact same thing. There's one very important thing to consider, which I'll get to, but other than that, they're almost identical. So look here. Look at this. I'm going to show you the problem and tell me if it makes sense, please. I've declared IC1. So what happens here? Allocates memory. Right? Allocates memory, puts 5 in there. And then we open up a brand new scope. This is a new scope. Once we open up that new scope, we declare a new object, IC2. Then we make a shallow copy of it. So can anyone tell me what happens here? What happens when we hit this bracket? What happens when we hit the bracket? It destroys it, right? Destructor is called. The destructor of this int container is called. So guess what? IC2's destructor is called. Where is that? Well, it's here. What does it do? It deletes that pointer. So now what happens? IC1, what does IC1 contain? Let's look at this. Of these things, what does IC1 contain? Give a few moments here. And I'll kind of restate it. This destructor is called. The destructor is called, so that pointer is deallocated. Synchro and 420 say dangling. It's a dangling pointer. That's exactly right. It's a dangling pointer. Do you understand why this is a problem? IC1 should still have its own memory, but thanks to the shallow copy that we made here, we now have some bad stuff going on in our program. We now have some bad stuff. So, with that being said, whenever we have a class that contains a pointer, we need to do the rule of three. What does that mean? We have to define all three of these. We must define all three of these members, always. And force them to make deep copies. We must force them to make deep copies. So I'm going to kind of speed run this a little bit. So let's force this one to make a deep copy. How do we do that? Well, we're going to say iPointer is equal to new int, right? Step one, allocate. And then the next thing we need to do is dereference iPointer, and we can say, hey, you are equal to the copy.iPointer. Step two, deref. Now it's a little mad at me. Well, maybe it's not. But I'll do that instead. Now there's one small problem here. There's one small problem here, and I'm going to highlight it. And I just want to see, you know, how intuitive we're being. This is hard stuff. Okay, so I just kind of want to see where we're at. Does anyone know what the problem with the highlighted thing is? Now, this is correct. This code will be in our function, but do you foresee any problems right here? And you have to think about these things whenever you're dereferencing pointers. And I'll just give a few moments for this one, because this is hard. It's a hard puzzle. Well, yeah, so we're dereferencing the copy. That's actually exactly what we want to do. In that we're going to want to say, hey, copy 5 into this value. Ali says it could have to do with its address, and that's right. So pretend this. Say this happens. So what if I did this? It calls the default constructor. So what is iPointer initialized to in the default constructor? You guys can tell me that one. What is the pointer inside of this object? What is it initialized to on the default constructor? It'd be null, right? And then I say, please make a copy of this. And so then we come into here, And what happens here? We dereference the null pointer. What does your program do? It dies. Your program dies. And you go, ah, why? Why did you do that? So yes, we need to check. Why did you do that? Yeah, exactly like in the destructor. Remember in the destructor we check for this? So if copy I pointer is equal to null pointer, then let's go ahead and just assign that value, but else we will allocate. Fair? Are we all on the same page here? Why are you doing that? The formatting is all weird. I missed something somewhere. I must have missed something somewhere. It's angry at me. Sigro asks... Well, so we'll start with Ali's question. Ali says, do you have to dereference the copy first? Well, here I'm going to check for it first. I'm going to check for the copy. If the copy contains a null pointer, then I know that I should not dereference it. Do not deref. Do not do it. And then just assign null into the new one, right? Do not dereference this. It contains null, right? So we'll just say this new one will contain null. Else, we know that this pointer contains an address. Therefore, we will allocate some memory for a deep copy, and then we will dereference both of them. All right. So Synchro said, oh, so I'm going to take that. I'm going to take that as I answered that question. So now we're going to move on to this one. Now I'm just going to kind of wave my hands a little bit. Well, I won't. I'll explain to you what's happening. All right, so this is almost exactly the same thing. All right, this is almost exactly the same thing as I said in the notes. So I'm going to copy it. But I'm wondering, does anyone see any... Man, why? I definitely missed something. I have to go find it. It must be in main. Anyway, while I'm looking for it, can anyone foresee any problems with this? Now, this part is 100% okay, all right? So I'm going to leave it at that. I'm going to say this does not have to be altered in any way. But does anyone foresee any problems here? And here's the hint. Here's the hint. Both of these objects will already be alive. So somewhere down here, I'll say like this. Say something like that. Maybe I initialize it to be 10. And then I'll say IC1 is equal to IC3. So that's the hint, all right? So while I'm looking for my screw up, the hint is that IC1 and IC3 are already alive at this point. So what am I missing in this code? Or what is the potential problem? Here, I'll show you. Of, I think you guys like it when I do this. Of these three things, of the dangling pointer, the memory leak, or the alias, are any of these likely to happen? I'm going to just compile the code and let it tell me where my problem is. Tell me where I'm wrong. Terry says, alias? It will not, I'll say it's not an alias. But I think you're close. And I'll show you. I just want this to tell me what's wrong. Tell me what's wrong. I mean, nothing's wrong. All right. It is a memory leak. A memory leak happens. Now I'll tell you why. At this point, recall that IC1 is still alive, all right? So do you guys, tell me if you don't understand this. The copy is IC3. Therefore, copy.iPointer is IC3's pointer. iPointer belongs to IC1, all right? So the thing is, IC1 is already alive. And if IC1 is already alive, then IC1 could already have a pointer that's been allocated. So guess what happens here? In actually both cases of memory, well, not in all cases, but in some cases a memory leak will happen. If iPointer contains an address, here we overwrite it, memory leak. If iPointer contains an address, overwrite it, memory leak. Do you follow? Do you follow that IC1 is already alive and it may have memory that's already allocated? And here a memory leak will happen, and here a memory leak will happen. So the very first thing we do is if iPointer does not equal null pointer, say goodbye. Return it. Do this first. Send it back. Say hello. And guess what? If you want to prevent the alias, do that. If you want to prevent the alias, do that. So this prevents memory leak. And then the rest of this is the copy constructor. All right? Isn't that weird? I know. I know. This stuff is not fun. I mean, I'm having a great time. But I know you guys are not. I'm having a fantastic time. But only because I've seen this for years at this point. And this is your first time seeing this stuff. So let's kind of look at our notes. We kind of solved that rule of 3 stuff. Right? So we must define all 3 of these members and force them to make deep copies. Or if destructor deallocate address. All right, so we've done it, right? We've done the hard stuff. And now we're gonna kind of, there's a few things we should do. And I gotta prioritize some of them. All right, I'm gonna prioritize the arrays. All right, so we're gonna probably come back to this one later, tomorrow morning. And I promise you guys that if there's like something that I really can't get to, I'm not gonna like put it on the test. I don't want to make things unfair. So if there's something tomorrow that I'm like, I don't think that we can remember for the test, I won't put it on there. But so far, this kind of stuff is going to be on there, all right? Shallow copies, deep copies. It's going to be on the review, so you'll have access to it. So at this point, I'm going to make a new file. And this is just going to talk about copying arrays, all right? Because this is what's going to be on the assignment. The new assignment will be going up probably today or tomorrow, but I won't make it due until later next week, so you can have time to study for the test instead. But for those of us who are into doing the assignments quickly, you'll have access to that. And you'll be able to do it after this quick little bit here. And to give you a hint, in the assignment, I'm going to make you make your own string class. And so the string class is going to have these things. I will give you the operator overload, but you're going to have to do all these things for the string class and make one of these pointers. So we're going to talk about arrays. And guess what? In the assignment, I'm going to make you make your own string class. And then when we get back to operator overloads, I'm going to make you take that same program that you wrote for assignment 4, and I'm just going to make you do operator overloads for that class. So it's going to be kind of a two-parter, this assignment. So if you think that's kind of cool, I think so too. So just because we haven't seen very much of the arrays, I'm just going to, kind of point it out. So let's make an array. So to make an array, we're going to make, maybe it'll just be ints, pointer array. I'm going to say, hey, how about you have a new size 5? And then somewhere in here, I don't know, I'll do a for loop. Let's do it in size. Let's say I initialize all of the values inside of the pointer array to be equal to something like that, 0. Now, why is this okay? Because this bracket dereferences it, right? Remember, I am dereferencing it here, all right? Remember, I am dereferencing it. So don't be confused when you see that bracket, all right? Whenever you see a bracket, we are making a deep copy. Whenever you see the bracket, you are making a deep copy. Let me prove it to you. It's in the notes. Where is it? It's here. You are making a deep copy, all right? So remember that. It's the same thing. You are dereferencing it. So now, I want to add something to this array. Do you think this is okay? Say I say size plus plus, and then I say pointer array located at 5 is equal to 0. Do you think that's fine? .420 says yes. Well, it'll work. I promise you it'll work. But did we actually resize? But no. This is bad. All right? Why? Because we were only given 5 times, we were only given 20 bytes of memory. What is this one? This one is located, so recall we are dereferencing it. We are dereferencing it. That's what the bracket does. We are dereferencing it. But we are dereferencing an address that was not given to us. The operating system only gave us 20 bytes. We are accessing bytes 21 through 24. This is bytes 21 through 24. That memory does not belong to us. That memory does not belong to us. This is bad. Your compiler will work. I mean, the program will be fine. So, yeah, so Cherry, you say it has to be 4? Yes, that's legal. But I'm trying to resize it. I want to resize it. I want to say, please make this array bigger. And so this is the bad way to do it. You know what we have to do? It's very tedious. Are you ready? Step 1. Yeah, 420. You have to copy it. That's exactly right. Step 1. Make a new pointer. Yes, exactly, Cherry. Make a new. We're going to call new again. Step 1. Make a new pointer. Int new array. equals to new int size plus 1. Made it bigger. Step 2. Copy, here, deep copy all the original elements. 4, I'll copy this. You don't need to. I don't like typing. For an I, size, blah, blah, blah. The new array located at I, remember, I'm dereferencing it. I am dereferencing it. Therefore, I am making a deep copy. I'm going to say it's equal to the pointer array located at I. Maybe we'll call this the old array for fun. Just so when you reference this code, it makes sense. Step 2, deep copy. So I'm going to copy the first 5 elements, right? Step 3, insert new element. All right. New array located at size is equal to new element, say 5. Step 4, increase the size. Now, if you guys are really efficient, you could do it here. All right, we're not going to really talk about that until operator overloading, but this would work just fine. But to keep things kind of clear and clean, I'm going to increase the size here. All right. And then, step 5, how many steps are there? Delete the old array. All right. Say goodbye, old array. Step 6. Assign the new array. And perhaps you want to prevent the alias here too. Synchro asks, you couldn't do it for the old array, but you can size plus plus for the new one. Why? Because this part here. Look at the difference between this one and this one. The new array is exactly exactly 4 bytes bigger than this one. It's exactly 4 bytes bigger than this one. So I actually made a new array that was 1 cell bigger. And so at this point, size is still equal to 5. Size is still equal to 5 at this point. Size is still 5. And then here I send it up to 6. All right, so this code is very important for the assignment, all right? I'm just going to leave it at this, pretty much. I'm just going to leave it at this. So when you're inserting something, you basically have to do this every time. From here, step 1, make a new pointer. Request new memory. Rather, request bigger memory. Step 2, deep copy all of your old elements into it. Step 3, insert your new element. Step 4, increase your size. Step 5, say goodbye to the old one. We don't need it anymore. It's gone. Step 6, put that new array into the old array. Now this you might consider to be a shallow copy, but it won't be because we're going to remove the alias here. So at this point, it is kind of a shallow copy, but recall that we deleted the old array, so there's no memory leak. And right after it, we assign null pointer to new array to prevent the alias. So everything in here is 100% legal. Nothing bad will happen. Except then you're going to do some code here. And then down here, you're going to make sure that you delete that old array because you don't want any memory leaks. So I'm going to stop there. Tomorrow, we're going to have to do more pointer stuff. I'm sorry about it, but we're kind of crammed here. So, do you guys have any questions about this? I know it's scary. It looks hard and not fun. But before the end of the semester, I'm going to make you masters. Synchro asks, I delete twice. So, I will just point it out. Let's see. For every new, I must have a delete. For every new, I have to have a delete. So let's go count how many news I have. Here's one new. Here's two news. Now I need to count my deletes. There's one delete. There's two deletes. And so I know that doesn't really make sense, but I allocated this. And then before I assign the new array to the old one, I delete it. But now recall that a new array has been allocated. New array's already been allocated. So to answer Cherry's question, yes, I'm just transferring the address from the new pointer to the old pointer. And then once the address is transferred, this still contains allocated memory. So down here I have to delete it again. So for every new, there's one new, there's two news. I have to call a delete. There's one delete, there's two deletes. So that's always something easy you can remember. For every new, there must be a delete. Now the order does matter, all right? Notice that the delete has to happen here to prevent a memory leak. If I didn't call this here, we'd have a memory leak. All right, so at this point though, you have enough knowledge to get started and finish assignment 4. So whenever I get a chance to put that up, I will. I'm going to prioritize the review sheet today so I can get to that to you first, and then assignment 4 will go up after that. Cherry says you don't have to delete new array. By setting it to null pointer, that automatically gives it back. No. I transferred the address to the old array. So the old array now contains that memory. The old array now has that new address. And then this says, prevent my alias. I don't want two pointers containing the same address. So I just take the new memory and I give it to this pointer, and then I say I don't want it anymore. And then later down here, I do delete it. This delete old array corresponds to this allocation on the new array, right? Thank you. I'm glad that clears it up. This, right? This doesn't return any memory. This just moves an address from one variable to the next one. All right. So as I said, review sheet will be going up today. Assignment 4 today or tomorrow. I'm not going to pressure that on you guys since we have a midterm coming up. What else? Yeah, that's really it. Ask me questions. Assignment 2, it's due tonight. The late deadline is tomorrow, I think. So get that done. Ask me questions. Christine posted her adjusted office hours. If you can make them, you can. She's going to have your assignments graded by tonight, hopefully. And that's what I got for you. So thanks for coming to class today. Happy Friday Eve once again to all of you. Thank you for bearing with today's crappy conditions, connection issues, terrible people coming into the chat thinking they're funny, computer having a brain fart. Thank you for bearing with it and staying resilient. I hope you guys have a great day, and I will see you tomorrow. Thank you, Allie. Thank you, Cherry. You are welcome. Attacker, you're welcome. Synchro, you're welcome. Saro. Have a great day, guys. You're welcome, Coda. You are welcome, 420. You're welcome, Dr. Chowder. All right, stream goes by. See ya.